something is moving around us, and that is a air. We drink soft drink or tea, that is a solution. So solution जो कि एक क्लास 12th केमिस्ट्री का यूनिट है, जिसमें हम सिर्फ बाइनरी सॉल्यूशंस के बारे में पढ़ते हैं, एंड हम उसमें सिर्फ और सिर्फ कुछ ऐसे सॉल्यूशंस पढ़ेंगे जो कि किसी सॉल्वेंट के अंदर सॉल्यूट मींस सॉल्यूशन either can be a gaseous, can be a solid, can be a liquid, but in our 12th class syllabus we have to be read about the liquid solution in which a gas is present, a solid is present, and liquid is present in a liquid. So all together we have to be focused on the liquid solution and its three types. So let's take a small quick review about the chapter solution of class 12, that is the solution. And solution में we are having a three type of solution, that is solid solution and gaseous solution and liquid solution. We have to be see the three types of these solution, that is gas in solid, liquid in solid, and solid in solid. Same for the gaseous one, we are having, that is gas in gas, liquid in gas, and solid in gas. Same thing for the liquid solution, that is gas in liquid and liquid in liquid and solid in liquid. So these are the three main type of solution, and then they are further divided into three classes. We have to be focused on the liquid solution and the various laws applicable with it. So first solution हमारा हो गया, that is a homogeneous solution. क्या है? That is a homogeneous mixture of two or more substances, homogeneous mixture. But we have to be see or we have to be read only about the binary solution. Binary solution means only two part. The major part is known as solvent, जिसके अंदर चीज डिसॉल्व होती है, and the smallest one is known as solute. Solvent is the larger part and solute is the smaller part of a solution. Then we have to be read about the concentration of the solution. So concentration of solution, that is how we can find it out. Mass percentage, volume percentage, so various terms associated with it, that is mass percentage. Second one is volume percentage. Third one is mass volume percentage. Then we are having a parts per million, that is known as ppm. Then we are having this mole fraction, which is represented by x, and here we are having the molality, and we are having that molarity and molarity. So in दोनों में जो difference है, that molarity is depending upon the volume of solution, where the molarity is depending upon the mass of the solvent in kg. So out of these terms, this molarity is a temperature dependent. This is temperature dependent. Even this one, जहाँ जहाँ पे volume आएगा, that is the depend upon a टेम्परेचर. पीपीएम पे कोई फर्क नहीं पड़ेगा, मोलैरिटी पे कोई फर्क नहीं पड़ेगा, मोल फ्रैक्शन पे कोई फर्क नहीं पड़ेगा. वॉल्यूम परसेंटेज इज आल्सो डिपेंडिंग अपॉन दी, that is we called the temperature. So these are the terms which depend upon a temperature. As temperature change, the volume percentage, mass by volume percentage, and molarity will change. And then we have to be read about the solubility. solubility, solubility, that is solubility. And then we are having the percentage of mole fraction of a gas in a liquid, which is represented by, yeah, or can be explained by Henry's law. हेनरी लॉ को मैथमेटिकली अगर हमने एक्सप्रेस करना हो तो दैट इज द पार्शियल प्रेशर ऑफ अ गैस in a solvent or in a solution is directly proportional to its mole fraction, और हम इसे किस तरह से लिख सकते हैं that equal to KHX. यहाँ पे this is a partial pressure, this is Henry constant and this is the mole fraction. देन उसके बाद हमारे पास ये हेनरी लॉ अगर आ जाता है, हेनरी लॉ विल एक्सप्लेन हाउ द स्कूबा डाइवर्स will survive for long times inside the water while we are getting suffocated while we are climbing, and how the जो हमारे cold drinks हैं they are packed under pressure. So these are the various application in our day-to-day life where we are seeing the Henry law. And even the people who are living at high altitude, they are having the red skin because of the less oxygen in their blood. And then we are having the solution can be ideal solution, the solution which follow the Rod's law. Rod's law is stating that the partial pressure of a solute in a solvent solution is directly proportional to its mole fraction, where the proportionality sign will be omitted with the pure pressure of the that particular component. So how we can write that the partial pressure equal to pure pressure multiplied with its mole fraction in the solution, and this is the Rod's law. Rod's law, and Rod's law is a special case of Henry law. Both are the looking like the same here. The pure pressure is just equal to the Henry constant, and those solution which follow the Rod law, they are known as ideal solution, and those which are not follow the Rod law, they are known as non-ideal solution. For ideal solution, that delta mix volume में कोई change नहीं आया, that is 0. Delta mix enthalpy means while we are mixing, no heat will be coming out and no heat will be required, and the new force between the solute and solvent equal to जो उनके अपने particle के बीच में था. So this is the ideal solution की 3 क्राइटेरिया या कैरेक्टरिस्टिक्स है, एंड जो इसको फॉलो नहीं करता, इसमें से अगर कोई भी फॉलो नहीं कर रहा है, देन इट इज अ नॉन आइडियल सॉल्यूशन. एंड देन वी हैव टू बी रीड अबाउट द पॉजिटिव एंड नेगेटिव डेविएशन. व्हाट विल हैपन अगर इनमें से फोर्स जो है वो सेम नहीं होता है, आइदर इट विल गो बियॉन्ड द रॉड लॉ और इट विल बी बिलो द रॉड लॉ. सो वी विल हैव द पॉजिटिव डेविएशन. अगर पॉजिटिव डेविएशन है मींस जो हमारा ए बी न्यू फोर्स जनरेट हुआ है दैट इज वेरी लेस एज कंपेयर टू ए एंड बी बी. और अगर नेगेटिव डेविएशन है then the force between the two parts of a solution is greater than the AA and BB, where A is one part and B is a second part of the solution. और ये जो AA है that is the intermolecular forces between the atom of a solvent and solute. And then अगर इनमें से कुछ भी ऐसा होता है, if we are having a non-volatile means which cannot evaporate easily. So in that case, we will see four colligative properties related with the non-volatile solute in a solution, and that is lowering of vapor pressure, lowering of vapor pressure, vapor pressure. Second one is elevation of boiling point, elevation of boiling point. Third one is depression of freezing point, depression of freezing point. And the fourth one is osmotic pressure, osmotic pressure. So here we can mathematically express them, that is यहाँ पे जो lowering of vapor pressure है, that is क्या हो जाएगा, जो प्योर प्रेशर है माइनस जो प्रेशर कम हो गया है एंड डिवाइडेड बाय प्योर प्रेशर इक्वल टू the number of moles of solute divided by number of moles of solvent. Then elevation of boiling point, elevation of boiling point को हम किस तरह से मैथमेटिकली एक्सप्रेस करेंगे, that is delta TB, the change in जो boiling point है, and but I should write here, that is delta TB is equal to KB, that is the what we can, this is constant, it is known as molal boiling point molal constant, and it is also known as volumetric constant having the unit Kelvin kg per mole and molality. Then we are having depression of freezing point, that is Kf, that is depression or lowering or depression molal depression constant or cryoscopic constant multiply with the molality. And the last one is osmotic pressure, that is pi equal to CRT, or C can be written as number of moles of solute divided by volume of a solution into RT. So these are the four qualitative properties which will be depend upon the number of solute particles in the solution, where the solute is a non-volatile, it cannot be evaporate easily. So we will see this type of properties attached with the solution, and then how we can see कि जो हमारे solute है either it got associate or dissociate while it present in a solution, तो हम किस तरह से कैलकुलेट करते हैं उसे, that is Went Hoff factor, Went Hoff factor, which can be symbolized as I, and it is denoted as or related to normal mass to abnormal mass, or I can be written as, that is colligative property, after association or dissociation divided by colligative property before association and dissociation, before association और डिसोसिएशन. सो यहाँ पे जो आई है हम इसको इस तरह से कैलकुलेट कर सकते हैं